Elementary statistics, measures of dispersion. Learning outcomes. After studying this topic, you will be able to know about the concept and definition of measures of dispersion, objectives of measures of dispersion, absolute and relative measures of dispersion, methods of measures of dispersion, range and coefficient of range. Definition of measures of dispersion. The degree to which numerical data tend to spread about an average value is called the variation or dispersion of the data. Earlier, we studied measures of central tendency. Average that represents the series as a whole. Average means mean, median, mode, any. But if we have to find out how far the various values of the series tend to disperse from each other or from their average, then we have to study measures of dispersion. Objectives related to measures of dispersion. To know the variation of different values of the items from the average value of the series. Supposing we have mean, median, mode, so we have to find out how much the value of x varies from the central tendency. Second, to know about the composition of a series or the dispersion of values on either side of the central tendency. Third is to find out the range, that is difference between the highest and the lowest value. Fourth, to compare the disparity between two or more series in order to find out the degree of variation between the two series. Lastly, to know whether the central tendency truly represents the series or not. For all these, we have to study measures of dispersion. There are two types of measures of dispersion, absolute and relative measures of dispersion. Absolute, when dispersion of the series is expressed in terms of original unit of the series. It is called absolute measure of dispersion. For example, dispersion of price series would be expressed in terms of rupees. Dispersion of weight series would be expressed in terms of kilograms. But this absolute measure cannot be used when comparison is involved across two or more sets of statistical series with different units of measurement like rupee and kilogram. Rupee in one case and kilogram in other. For that, we use relative measure. The relative measure of dispersion expresses the variability of data in terms of some relative value or percentage. For example, if we say 26% of the people in India are below poverty line, so that means we are referring to the relative variability of data. This measure of dispersion is used when we study two or more series simultaneously. Relative measure of dispersion is known as coefficient of dispersion. There are different methods of measuring dispersion. First, based on spread of values, for example, range and quartile deviation, interquartile range, and their relative measure is coefficient of range, coefficient of quartile deviation. Second measure of dispersion from average. There are two in this, mean deviation, standard deviation, and their relative measure is coefficient of mean deviation, coefficient of standard deviation, or coefficient of variation. Lastly, graphical measure of dispersion, Lorentz curve. Now we are going to concentrate on range and coefficient of range in this video. So range, what is range? It is the simplest method of measuring dispersion of data. Range is the difference between highest value and the lowest value in the series. The formula of range is, the range is highest value in the series minus lowest value in the series. There is one example for 5 students. If their pocket money is 20, 30, 40, 50 and 100 per month, the highest value is 100 and lowest is 20. So we can find out range 100 minus 20, that is 80. Now, coefficient of range, relative value. Range is an absolute measure of dispersion. To make it comparable, we use coefficient. Coefficient of range is highest minus lowest upon highest plus lowest. Means it is the ratio between the difference between the highest and lowest values of the series and the sum of highest and lowest values of the series. So formula will be like this. This example, the pocket money example, so we can find out the range. 100 minus 20 is 80 was the range. If we have to find out coefficient of range, 100 minus 20 upon 100 plus 20. 80 upon 120, that is 0.67 will be the coefficient of range. Up. Now we'll do the sums one by one in different series. First we'll take up individual series. This example is given. Only x, value of x is given because it's an individual series, no frequency, no class interval. So what will we see? We'll see the highest wages, they are 500 and lowest is 50. So we can easily find out the range. 500 minus 50, that is 450, and coefficient of range is 500 minus 50 upon 500 plus 50. And if we calculate, we'll find the answer 0.82. Second question is from discrete series where we have x value and frequency, but there is no class interval. So for this, frequency of the series is not taken into account. This is most important. We have to find out range from x. Now what is range? Highest minus lowest. Highest is 18. Lowest is 10. 18 minus 10 is 8. And coefficient of range, highest minus lowest upon highest plus lowest, that is 18 minus 10 upon 18 plus 10, and the answer is 0.29. Now question 3, we are taking continuous series. So this is the question. See in your screen, it's the question of inclusive series. If we get inclusive series, first we have to convert it into exclusive series. So we have already converted it, and marks are given, that is class interval x and number of students. Number of students is frequency. Again, frequency of the series is not taken into account. We have to find out from the value of x. So range will be 69.5 minus 19.5, that is you can find out 50, and when coefficient of range is there, so 69.5 minus 19.5 upon 69.5 plus 19.5, and the answer is 0.562. Now merits of range. Merits of range, it is very simple to calculate and simple to understand. Widely used, range is widely used in a statistical series relating to quality control in production. Quality control charts are prepared on the basis of range. If the quality of goods produced is within the range prescribed in the charts, then the production process is said to be under control, otherwise not. Similarly, range is commonly used measure of dispersion in case of changes in interest rate, exchange rates, and share prices. Now the demerits. Demerits of range. It is an unstable value. Unstable because any change in extreme values or a change in the sample immediately affects the range of the series. Second is, it is not based on all values because we give importance to only extreme values. So we don't take into account the other values. Third is no knowledge of the formation of series. Range gives no precise knowledge about the formation of series. Fourth is irrelevant for open-ended frequency distribution. Open-ended frequency distributions are there when the upper limit of the first class interval and last and upper limit of the last class interval is missing. So there, because we are taking only extreme values, we cannot find out the range. Thank you. Have a nice day.